Hello and welcome along, Explorer. It's a brand new Fun Kids Science Midweekly. My name's Dan, and this is your brilliant bonus episode. A little bite-sized chance for us to search through the solar system. And it's all about your questions this week. If you ever have anything sciencey that you want answered, make sure you leave it as a voice note for me on the free Fun Kids app or at funkidslive.com, and I will do my best to do the digging to figure it all out for you. Here's a question from Anetha. It's a voice note. Thanks, Anetha.
Hello, my name is Anetha and I am 4 years old. And my question is, why can we not feel our bodies growing?
All right, why can't we feel our bodies grow? We don't feel our bodies grow for a few reasons. The main one is that we don't have a sense to feel growth. Our bodies have nerves. Those are the things that detect a feeling for pain, for touch, for temperature, for position, but not for growth, not for your bones stretching or your cells dividing. So there isn't a proper way to feel it. Sometimes you might feel something because you're growing when it puts a stress on your tissues. Those are the muscles and fibres which surround the bone. Well, you might feel growing pains there, like your legs are being stretched out. Some people get those really bad. I used to get terrible growing pains. Oh, they would ache and ache and ache all night long. But that's your tissues that are being stretched out. And your tissues, your muscles can feel things. But that's a bit unusual because normally the growth in your body happens quite slowly. It's gradual. Your body gets used to it. It barely notices that it's happening. It's like when you're travelling fast in a car. At the start, when it's accelerating, you notice the change in speed. But when you're there and you're on a road and the car's going quite quickly, well, you don't notice that, do you? Because you've got used to it. It's the same with your body. The growth is happening over such a long amount of time. You're just used to how it feels. And growth is too slow. It's too smooth and it's too inside your body for you to properly feel it, Anetha. Thank you for your question. Here's something else. It's all about your body. This is from Kiara, who wants to know, what makes our skin? Well, skin is an organ, just like your heart, your lungs, your liver. It makes about 16% of your weight. It's got a few layers. There's the epidermis, that's the outer layer, which is a waterproof barrier. It creates skin tone, and it kind of protects the top layer of protection for anything that might want to get through your skin. Beneath that, you've got the dermis. That contains tough tissues, the hair follicles, the sweat glands as well. Beneath that, you've got the hypodermis. That's made of fat and tissue, which connects the skin to what's beneath it, the bone, the muscle. Skin is mostly made of different proteins. There's keratin, that's in nails and hair. Also collagen, elastin. These are in what is in the cells that make up your skin, Kiara. Thank you very much for that. We've got more questions about making stuff in just a second. Let's travel back in time. Here's a question from Kaleb. Hey, Kaleb. Was there a dinosaur that could fly? Well, have a think. Do you think there was a dinosaur that could fly? Wrong, there wasn't. You said pterodactyl, didn't you? Well, not really. You see, not proper dinosaurs. There were reptiles around at a similar time to the dinosaurs who could fly, but proper dinosaurs themselves could not. We're talking about the pterosaurs. Terror, but it's got a silent P at the start. And they ruled the skies from the late Triassic period to the end of the Cretaceous period. So that's about 228 million to 66 million years ago. Those pterosaurs, they were flying lizards. You had the pterodactyl, the pteranodon, and the pteranodon, and a few more in there as well. But they weren't proper dinosaurs, Kaleb. So, no, there wasn't really a dinosaur that could fly. Something very similar, though, up there. Thank you for your question. Here's one from Nathaniel. From Belfast. Hey, Nathaniel, why do we have eyebrows? Eyebrows do a few different things. Stuff you might not realise as well. Originally, we evolved them to keep rain and keep sweat out of our eyes. We need our eyes. We don't want anything in there, particularly water that could blur the vision. So it would protect them from that. Also keeps sun away from your eyes, bit of dust as well. That's clear. Eyebrows have also now taken on another function, and that's to kind of help us talk to each other. We've evolved to use them to understand each other, because a raised eyebrow might mean you're curious or you're angry. So we've developed a way of talking silently using just the strange, sometimes very subtle movements of your eyebrows, Nathaniel. So that's why we have them, for a few different reasons. Thank you for your question. Here's another one. It's a voice note.
Hello, my name is Sedar and I live in Dhaka, and my question is, what are chemicals made of?
Okay then, what are chemicals made of? Well, a chemical is a substance made of elements. Something made of matter, of solid, a liquid, or a gas. So water is a chemical, that's H2O. It's 2 hydrogen atoms for 1 oxygen atom. They join together and they make water. Carbon dioxide, that's another chemical, CO2. So you've got 1 carbon atom, 2 oxygen atoms, they join together to make the gas. So chemicals are made of atoms that you've just heard about. They are the building blocks of all matter, like the Lego pieces that join together to make just a stunning and very smart picture. You might have a chemical element, that's just 1 type of atom. Oxygen, bam, chemical element. You might have a chemical compound, which is different types of atoms joined together. So all chemicals are made of atoms, the building blocks, as I say. But what's inside an atom? Well, you've got subatomic particles, tiny, tiny, tiny things. You've got a proton. Those are positively charged particles that are right in the middle, in the nucleus. And the amount of protons decides what kind of element it is. You've also got a neutron, that's a neutral subatomic particle, that's in the middle, that's in the nucleus as well. And around the outside, you've got electrons, those are negatively charged particles, and they spin around the outside just like planets orbiting the sun. So, a chemical is made of an atom, which is made of subatomic particles. Thank you for your question. If you have anything sciencey, make sure you leave it as a voice note for me on the free Fun Kids app or at funkidslive.com. Right, we've learnt loads with these questions. Shall we learn some more and head into space? Didn't have any questions on space today, actually, I think. No, we didn't. So let's head into space now and get a lesson from the smartest school in the solar system, Deep Space High.
Deep Space High, marvellous missions with the Science and Technology Facilities Council. Jump into a wormhole and travel to Deep Space High, the school in space. But hurry, because lessons are about to begin.
Quark.
Here, sir.
Alex.
Here, sir.
Blurp. Helix.
Here, sir.
Stats. Stats? Stats? Would you mind telling me why you have brought a space pigeon into class?
Chirps isn't a space pigeon. He's my pet Pegasus falcon. They have the best eyesight of any bird in the galaxy. I'm sorry, sir. He must have hopped in my rucksack this morning.
Well, he might have better eyesight than you, Stats, but he won't be able to compete with some of the space telescopes from Earth that we'll be studying today. I've got some lovely holograms for you to study.
Pegasus falcons can see all parts of the electromagnetic spectrum and to a distance of over 100 kilometres. I'm not sure any Earth telescopes can compete with that.
Well, let's see, shall we? Stats, find a box for the bird, and everyone pay attention. Dim the lights.
Wow, it's the night sky, right inside the classroom. There's hundreds of constellations.
So here's some space. We all love looking at it, but our eyes only see part of the light that's travelling from those constellations. They're not very sensitive to make out much. It's just a lot of dots. So what do?
Get some glasses?
You're on the right lines. We use telescopes that can pick up light from distant objects like stars and planets and magnify the light to make things appear closer. They can also pick up other sorts of waves that our eyes can't detect. radio waves, for example, and even infrared. Yeah, have a look at these.
It's like an army of satellite dishes, but they're massive and in a desert.
They're not satellite dishes, they're radio telescopes. They scoop up radio waves from millions of light years away and put together pictures from the farthest reaches of the galaxy. What you're looking at is still under construction, but it will be the biggest array on Earth, with a total of 66 antennas. It's in Chile, and they're called the ALMA, Atacama Large Millimetre Array. The trouble with looking up at space from Earth is that you get a lot of interference, a haze of radio waves that distort the images coming in. The obvious solution is to get as far away as possible from all that and go... Where, anyone?
Into space.
Exactly right. Stick your telescope in space and you'll see an awful lot more, and it will look a lot more interesting. Here's a whopper for you. It's called the Herschel telescope. It's around 1.5 million kilometres away from Earth, and it's designed to pick up infrared waves. Pretty big, isn't it? The mirror is over 3 metres big. Here's a hologram of another very famous space telescope. Anyone care to take a guess?
Me! It's the Hubble Space Telescope. It launched in April 1990 and orbits at around 600 kilometres above Earth's surface. It's really helped humans find out more about all sorts. The age of the universe, gigantic black holes, or what stars look like when they're dying.
And produce some amazing pictures, like the Cat's Eye Nebula, my favourite, although it does look like a ginormous tin can with wings.
Hang on! Didn't they have to put a contact lens on it, sir? Because they made the mirror the wrong shape?
Nearly. The mirror had a microscopic imperfection that made the pictures blurry. But it was corrected on its first servicing mission, so there's no need to laugh. Hubble is an amazing piece of Earth technology.
Trust humans to make a mistake with something as simple as that.
Hey, watch it. Your space pigeon couldn't see that far.
He's a Pegasus Falcon!
Be quiet, the lot of you. Hubble's worked hard, but he's set to be replaced by the biggest space telescope ever built. Here's a hologram so you can see what it looks like. It's the James Watt Space Telescope, set to launch in 2018.
Whoa, that is the coolest thing I've ever seen. The mirror is made up of golden hexagons, and it looks like it's resting on beautiful curved sails.
Its mirror is over 6 metres in diameter. That's more than twice as big as Hubble's. NASA and the ESA, two big space organisations, got together with a company called Ariane Space to build it, and I, for one, will be very excited to see what pictures it comes up with. Which brings us to the end of today's lesson. Now, please don't forget to take all your belongings with you, and that includes you, Chirps.
Deep Space High, marvellous missions with the Science and Technology Facilities Council.
And that is it for this week's Fun Kids Science Midweekly. Yeah, if you've got any questions, make sure you leave it as a voice note on the free Fun Kids app and at funkidslive.com. You can hear more at Deep Space High and loads of brilliant podcasts that we've got on Google, Apple, Spotify, wherever you get your shows. They're on the free Fun Kids app and at funkidslive.com too. Fun Kids, we are a children's radio station from the UK. You can listen all around the country on our app, on our website, and the easiest way, if you've got a smart speaker, wake it up and ask it to play Fun Kids. And I'll see you soon.